All right, let's talk about a really clever Python library that tackles a problem I'm pretty sure every single one of us has run into.
You know the feeling, right? Your app's just humming along, everything's fine, and then bam, the memory usage just explodes, goes straight to the moon. It's such a classic and oh, so frustrating headache.
This happens all the time in systems that are handling a ton of data, like a busy logging service or a data pipeline. A sudden wave of data comes in, your in-memory queues just swell up like a balloon, and suddenly they're eating all your RAM and your app just grinds to a halt.
So what if there was a way to handle all that data without that insane memory penalty? Well, that's exactly the problem a library called Quez was built to solve.
Okay, so what is Quez? Well, think of it as a drop-in replacement for Python's standard queue, but with a superpower. It automatically, and this is the magic part, it automatically compresses data the moment you put it in and then decompresses it when you take it out.
And that word transparently is so important. It means you don't have to change your logic at all. You just use it like a normal Python queue, but behind the scenes, it's doing all this heavy lifting, just absolutely slashing the memory footprint of all that data flying through your system.
Okay, but how does it actually do that? Let's pop the hood for a second. The best way to think about it is like you're vacuum sealing your data before you put it away.
So when you call put on some object, Quez does a few things automatically. First, it serializes it into bytes, usually with pickle. Then it takes those bytes and squeezes them down with a compression algorithm like zlib. Then it stores that much smaller result. And when you call get, it just does all of that in reverse. It's simple, it's automatic, and man, is it effective.
But here's the thing, that simple compression is really just the beginning. Quez is also a super flexible tool, so let's get into some of its other really powerful features. No matter what your flavor of Python is, Quez has got your back. Are you building a classic multi-threaded app, or are you all in on modern asynchrono? Doesn't matter. You get two different classes, one for sync and one for async, and the APIs are going to feel totally familiar right out of the box.
And for all you asynchronous developers out there, this next part is huge. We all know compression can be a real CPU hog, right? Well, Quez is smart. It offloads all that heavy compression work to a background thread pool. What does that mean for you? It means your main event loop never gets blocked, it stays snappy and responsive, which is, the whole reason we use asynchronous to begin with.
Okay, this is where Quez really starts to shine for me. It's not a black box. You have total control over the compression. You can stick with the built-ins, or with just a simple pip install, you can swap in a high-performance backend like zstand. And if you have some super specific unique need, you can literally write your own compression algorithm and plug it right in. How cool is that?
So you're probably asking, which one should I use? And the answer is, well, it's all about trade-offs. zlib, that's your solid, dependable default. It's a great all-rounder. If you need to squeeze every last byte out of your data, and you don't mind if it's a bit slower, then LZMA is your go-to. But honestly, for that perfect sweet spot of incredible speed and really good compression, ZSD is pretty much always the winner.
Okay, that all sounds great in theory, but talk is cheap, right? Let's see the proof. How well does this thing actually work?
All right, let's run through a quick little example. Super simple. We're going to take a string with 1,000 random characters. We'll create a default Quez queue and just pop that string right in there.
Now, one of the coolest parts of Quez is this handy little .stats property. It lets you peek inside and see exactly what's going on. So, let's ask it, what did it do with our data? Whoa. Okay, look at that. 87%. That is an 87% compression ratio. That means our data is taking up a tiny fraction of its original space in memory. That is a game changer.
Let's break that down. The original data, once it was turned into bytes, was over 1,000 bytes. After Quez did its thing, just 131 bytes. That's insane. And having that little stats dictionary is just fantastic because you can see exactly how much you're saving, right there in real time.
So we've seen it's powerful right out of the box, for sure. But the real magic, the real strength of Quez is in that pluggable architecture we touched on earlier. See, it's not just about swapping out the compression. By default, it uses pickle to serialize your objects, right? But you can just as easily replace that. Maybe you want to use JSON or something else entirely. You can. This means you can customize the entire pipeline to fit exactly what you need.
So the big question is, when should you reach for Quez?
Well, think about streaming data pipelines. Think about high-throughput logging systems, or anytime your app has to deal with these huge, sudden bursts of data and you're worried about it falling over from memory pressure. Basically, anytime you need to manage a bunch of in-flight data without blowing up your RAM, Quez is your friend.
And that kind of leaves us with a really interesting thought, doesn't it? Quez takes this super standard, familiar tool, the Q, and just gives it superpowers by making it pluggable. It really makes you wonder, what other parts of the standard library could be totally transformed with a design like this? It's a powerful idea to chew on.